If those are my factors, will I get this exact shape, do you think? Or am I missing something? What am I missing? I've got the x-intercepts. I'm missing, I don't have the correct degree. How do you know that I don't have the correct degree? Both ends are going up. So is this even degree? Currently not. Finn? I have to square the x minus 2 so that it bounces off at 2. So let's see if I plug this into my y equals menu, how close it looks to this graph. So x times x minus 2 squared times x minus 3. Let's just see if we get the gist of the, oops. So it looks pretty close, right? Comes down, has a minimum, bounces off at 2 and goes up. I don't know the steepness of the curve, but you kind of get the idea of how to build a function from a graph based on its x-intercepts. All right, so let's see about the next question. So number 2, now we're going to look at this polynomial function, and it asks what family of functions is it a member of? Basically, it's asking you, is it a polynomial or not, and what is its degree? So it's a polynomial, and more specifically, what is its degree? Yeah, cubic, right? So what family of functions? It goes with a cubic function. Based on its equation, sketch the shape of the graph without using a graphing calculator. So what are my x-intercepts? Give me the 2 x-intercepts. So I plot an x-intercept at positive 2 from x minus 2. Or x minus 2 gives me an x-intercept at positive 2. X plus 5 gives me an x-intercept at negative 5. Those are my 2 x-intercepts. Now I need to include the end behavior and the bouncing off kind of information. What's the leading coefficient for this function? Positive 1, right? So what's going to happen over here? To the right of this x-intercept, what's going to happen? It's going to go straight up. Is this a odd or even degree? Cubic, odd. So from this x-intercept, should I be going up or down? Down. Now you just got to fill in the middle. So by filling in the middle, what I mean is it going to bounce off or cut through these x-intercepts? Well, at negative 5, isn't it going to bounce off? So I touch negative 5, then I bounce off, and then I'm going to cut through at, what is that, 2? So something like that. So now it says, use your graphing calculator to see how close you got. X minus 2 times x plus 5 squared. So I did not have the steepness correct, but I have the gist. Down, bounces off, down again, and then straight up. So see what I mean by sketching? You've got some general gist of the shape, right? I know it's not parabola looking, right? It's got this thing bouncing off, cutting through. And it says, we already know how the x-intercepts are related, right? They're the opposites of the factors. Opposite of factors. So this was an exploration. We already know more than what this is asking you. And it just says, reading from left to right, describe the graph. It just means like, hey, you're increasing, then you're decreasing. So from left to right, you know, you're increasing when x is to the left of negative 5, right? Up to x equals negative 5. You'd have to find the minimum, right? It's decreasing down to a minimum, then increasing again, and then it's increasing from there. We didn't find this minimum value. I don't know. It bounces off when the factor is being squared. So, or 4th degree, because that's also even. So I'm just going to write etc. right here, because I don't want to go into a lot of detail. I don't want to find the minimum, and that wasn't part of this. All right, so examine this equation. How many distinct factors does it have? How many would you say? 3. I mean, technically, I guess you could count 2 as its own factor, but when they mean factors, they mean that have x in them. How many x-intercepts would you predict? 3 x-intercepts. So sketch the graph. So let's, without using a calculator, how would we sketch this graph? Where are the x-intercepts going to be? One of them is going to be at +2. One of them is going to be at -2. And one of them is going to be at +3. So +2, +3, and -2. And let's think about our end behavior. Leading coefficient is positive. So that tells me I go straight up from the right side of the graph. We already said the degree was odd. So I'm going to go straight down from the left side of the graph. It's going to cut through each of these points. So cut through, cut through, cut through. So some kind of snake like that. It never bounces off. It just kind of curves and keeps going. And it says, does the factor 2 have any effect on the x-intercepts or on the shape of the graph? So I'm not going to answer the rest of this because I want to get to the next part. You kind of get the idea of we're using multiplicity to draw the graph, right? Here's what I want to get to, the second page of 334, because this is kind of the big idea that I want to end with today. Putting it all together. It's kind of putting so much together from this whole year. That's why I didn't want to just skip polynomials. All right, so these questions go with the graph above it. So I'll do one and let you try 2, and maybe we can even try 2 as a warm-up tomorrow if we don't have enough time today to finish it. But what would be the lowest possible degree of this polynomial? Could that be a linear function? What do you think? What do you think your guess is for what type? I think it's 3. Why do you think the lowest degree is 3? How many turning points does it have? So if it has 2 turning points, it has to at least have a degree of 3, right? One more than the turning points. What would the leading coefficient have to be? The right end is going up. So the leading coefficient has to be positive. It says find all your x and y intercepts. Well, it looks like I have an x-intercept at 3, 0, another x-intercept at -2, 0, and another x-intercept at -4, 0. What's my y-intercept? -8, 0, -8. Those are my x and y intercepts. All those points are on my graph. Are you with me at that part? So now it says determine all the linear factors and their multiplicities. Well, all the multiplicities are going to be odd, right? Because it cuts through at each one. So let's write a function. Y equals, I'm going to write A for the steepness. What are my 3 factors? If 3 is an x-intercept, x minus 3 has to be a factor, right? If -2 is an x-intercept, x plus 2 has to be a factor. If -4 is an x-intercept, x plus 4 has to be a factor. How do we know that which one? A is a stretch factor. There's no x value there. So to find the stretch value, it's the same as when we did our quadratic launches. Remember we had to plug in that other point for x and y and solve for a? Same for polynomials. Well, guess what your extra point is going to be? Your y-intercept. So the last step to solve for our equation, and we'll just do the next one together tomorrow, but you're going to take the -8, plug it in for y. We don't know the stretch factor. We're going to plug in 0 for all of the x's. So that will give me -3 times +2 times +4, right? Because 0 minus 3, 0 plus 2, 0 plus 4. What is that number? -6 times 4 is -24. How would I solve for A as my last step? How'd you get that? What was your step that you just did in your head? Yep, so you'd have 1/3 equals a because you're taking -24 and dividing it to the other side. So your final equation is just that whole thing with the 1/3 in front. So you just saw the short course on how to find the equation of a polynomial if you know the factors and you know the y-intercept. And it's a cubic function. It should all fit together. So all of your knowledge kind of fits together like a puzzle. All right, so it is time to end.